Okay, I know you think this is this section that will never end. That's not true. This is the last of it, and I want you to be familiar with it so that we can answer questions quickly and try to move on to a modular system on Monday. So, we're going to talk real quickly about binary, octal, and hexadecimal systems. As we've mentioned, digital devices such as computers, MP3 players, and iPhones use the binary system. You might think of the ones and zeros as representing on and off commands, controlling microscopic switches on electronic chips. So the values 0 and 1 are called bits, which is a contraction of the word binary digit. A video chip in your smartphone, for example, may use the 16-bit binary pattern 1011001101101110 to represent red. But because it is tedious to remember such long strings of bits, often we rewrite these commands in a form that is easier for humans to remember. So these two tables right here show you what binary binary digits make up octal and hexadecimal. So you're welcome to attempt to memorize these. I'm going to show you how to work through it on your own, whatever works for you. I do want to point out that 3 binary digits make up 1 octal because 2 to the 3rd power equals 8. And 4 binary digits make up a hexadecimal numeral because 2 to the 4th power is 16. So just in case you're wondering where that comes from. And so octal being 8 and hexadecimal being 16. So in your notes, example number 7, we are going to convert that red bit string to both octal and hexadecimal, and I've already split that up for you. I've done some grouping so you can take some time to copy this down. I want to point out that I'm grouping from right to left, and that for the octal notation I am grouping in 3s, and for the hexadecimal notation I am grouping in 4s. But it's very important that you are grouping from right to left, just like we add and subtract and multiply. Well, not divide, but everything's from right to left because it's building from a units place to in this case, an eighths and 64ths. But you think of it often as ones, tens, hundreds, so forth and so on. But we're always starting and building from the units. So these, now that they're grouped out, remember that this is a binary number. It is still a binary number. That has not changed. So this is 0 times 2 to the 0 power. And this is 1 times 2 to the 1st power. And this is 1 times 2 to the 2nd power. And that is going to be the same for each of these little groups. So we're not going to keep getting larger and doing to the 3rd, to the 4th, to the 5th. That's not what we're doing. We're starting over each time from 0 because that's the whole point of grouping it out. Otherwise, you would just be writing it as just base 10. Like, that doesn't even make good sense. So again, we're starting over and we're doing times 2 to the 0 power, times 2 to the 1st power, times 2 to the 2nd power, and you are adding all of those up. So basically, you're just adding up the numbers 4, 2, 1, and 0 because that's all you're going to have. So 4 plus 2 plus 0 is 6. And 0 plus 2 plus 1 is 3, and 4 plus 0 plus 1 is 5, and 0 plus 0 plus 1 is 1, and 0 plus 2 plus 1 is 3, and 1 is 1. And that is your base 8 or octal answer. Now, obviously you would not space them out this much when you're writing your answers, but I write really poorly on the MacBooks, so I'm not going to attempt to rewrite. So when we're doing this with hexadecimal, it's that same system, except for we're going to go up one more power. So now we have times 2 to the 0 power, and we're grouping in 4s, times 2 to the first power, times 2 to the second power, times 2 to the third power. So with hexadecimal, you're basically working with 8, 4, 2, and 1, and then of course 0. So 8 plus 4 plus 2 plus 1, or excuse me, 0. So 8 plus 4 plus 2 plus 0 is 14. And I'm going to go ahead and write 14, but I'm going to remind you that this is a hexadecimal system. This is base 16, so we have to use E. So 0 plus 4 plus 0 plus 1 is 5. And 0 plus 0 plus 2 plus 1 is 3. And 8 plus 0 plus 2 plus 1 is 11. But again, it's hexadecimal, so you can't use 11. You've got to use B. So your final answer here, extend this page. Your final answer here is going to be, and I am going to rewrite this just because I had that cross out, is B 3 5 E 16. So again, going from binary to hexadecimal. Now these next two you don't have in your notes. These next two are going to come straight out of your homework. I don't know why I didn't create notes on these, but I didn't. So they're going to come out of your homework. So go ahead and get that out if you haven't already. And we're going to look at numbers 67 and 69. So numbers 67 and 69 have us going from one system going really in the opposite direction. So we're converting the 2, 4, 6 base 8 into binary. So I'm going to show you with the 6 how each of these works, but I'm not going to do it each time. So remember, if you're converting 6 into binary, you divide by 2, which is going to be 3, remainder 0, and then, whoops, that should be a 3. Divided by 2, it's going to be 1, remainder 1. And then if you do 1 divided by 2. You're going to have 0 with a remainder of 1. And when you write these when you write these from right to left, you get 1, 1, 0, which makes sense because 4 plus 2 plus 0 is 6. And 4 plus 0 plus 0, you could do it with the division if you needed to, equals 4. And 0 plus 2 plus 0 equals 2. Now you don't necessarily need this leading 0, so your answer ends up being 1, 0, 1, 0, 0, 1, 1, 0. And this is now a binary number, so it's base 2. I don't know, that little dash. Forgive me. The same thing is true with the hexadecimal system, except for you're dividing these numbers by, well, you're still dividing by 2, but they're just going to be a little bit larger. So I will do the first one, especially since the first one is not a number you're used to. E is, in the hexadecimal system, is equivalent to 14. So 14 divided by 2 is 7 with a remainder of 0. 7 divided by 2 is 3 with a remainder of 1. 3 divided by 2 is 1 with a remainder of 1. And 1 divided by 2 is 0 with a remainder of 1. So remember, you stop when your quotient is 0. So when you write these, you get 1, 1, 1, 0. And you should, because 8 plus 4 plus 2 plus 0 equals 14. So to get 3, you would have 1 plus 2, so 0, because you got to use that 2 to the third, 0, 2 squared, plus 2, which is 1 times 2 to the first, plus 1, which is 1 times 2 to the 0. And A, or 10, would be 8 plus 2. So 8 plus 2 is going to be 8 plus 0 plus 2 plus 0, because 1 times 2 to the third is 8 plus 0. 1 times 2 to the first is 2, and then plus 0. Again, it's a binary number, so it's going to be base 2. And there's your answer. So I'm going to leave those with you. I would suggest that for 73 and 74, is that 70? Wait, excuse me. Let me go back and look. For the next 71 through 74, the easiest thing to do is to convert those numbers into binary, so the numbers you're given into binary, and then convert the binary numbers into the either hexadecimal or octal, what you are asked for. And I think in the homework answer key, I do a pretty good job of showing that. So we're going to go over all of this, and I would like for you to finish through 74 to the best of your ability. I'm available tomorrow morning, Friday, November 4th, and after school as well. And I will also be available Monday morning to clarify anything you'd like for me to clarify. So I hope you've enjoyed this almost as you enjoyed the video on Wednesday, and I will see you soon.